Okay, so let's walk through this example. We're going to be using a data set that's available in lab data sets called Attitude. And in this data set, several people were asked a survey question: how do you like Springdale Mall? Or, how do you like something? Maybe you've seen these before. Typically, they're on a Likert scale, something like 3 is neutral, 4 is you like something, 5 is you very much like something, and then you go the other way for very much disliking something. So a marketing research firm surveys local residents. They ask them several questions about themselves and their preferences regarding local malls. The one question that we're going to focus on is their general attitude towards Springdale Mall on a scale from 1, dislike very much, to 5, like very much, where 3 is neutral. Of the 20 respondents, the mean and the standard deviation of the ratings were as follows. So the sample mean was 3.75 and the sample standard deviation is 0.85. Now, we want to walk through a hypothesis testing procedure that is scientifically correct. And what I mean by that is that we're going to define our decision criteria before we test the null hypothesis. Now, this may seem like a minor step, but it's actually quite important, because if we do this in reverse, we test the null hypothesis and then we decide that we draw the decision criteria, there is a threat of making a larger than expected type 1 error, or rejecting a true null hypothesis. So, step number 1, can we conclude at an alpha equals 0.05 level, and that corresponds with a 95% confidence interval, that the average attitude towards Springdale Mall among local residents is significantly positive? Now you'll notice that this question is stated such that it is a directional test. We're interested if it's significantly positive or significantly more than 3. But we're actually going to run it in Excel, assuming that we don't really want to know if it's significantly positive. We just want to know, is it something different than 3? So the null hypothesis in this case is that the average responder is neutral, or the population mean equals 3. And the alternative, or H1 hypothesis, is that the population mean does not equal 3, or the attitude is not neutral. Now this may be either significantly positive or significantly negative. So if we reject the null, then we're really testing to see if it's greater or less than, which is different than the original question. We'll come back to that. Step 2, we decide what our decision criteria is, or we select the significance level. Now this is usually stated in the problem, and it's typically going to be an alpha of 0.05, so that corresponds with a 95% confidence interval. And unless otherwise stated, you can always assume that the alpha is 0.05. So a type 1 error means that on average, the attitude is not positive, but we state that it is positive. Or in general, we're rejecting a null hypothesis when you really should have not rejected it. A type 2 error, we would be saying that the average attitude is positive, but we state that it is not positive. So in general, by not rejecting the null hypothesis when you should have rejected it. Hopefully you can kind of see the connection there, where a type 1, we're convicting an innocent person. We're rejecting a true null hypothesis. Okay? Type 2 is that we're convicting, or excuse me, we're acquitting a guilty person. Or in this case, we are rejecting a null hypothesis, or excuse me, failing to reject a null hypothesis when it is actually true. So there's this trade-off between our type 1 and our type 2 errors. Step 3, we actually test this hypothesis. So we select the test statistic and calculate its value. In a single sample t-test, this is not extremely difficult because all we're really doing is asking the question, is this sample mean something different than the hypothesized mean? So the t-test, or the number of t-values that we are away from the mean, is equal to the sample mean minus the hypothesized mean divided by the standard error. And this is translatable into proportional terms as well, where the sample mean would become the sample proportion. The hypothesized mean would be the population mean, or population proportion, and the standard error would be the standard error of the proportion. So notice that this is the same exact equation for the z-statistic. The only difference is that which distribution we use to calculate the probability. Since the t and the z equations are the same, they both indicate the number of standard errors away from the mean. Identify the t-statistic on the sample distribution. So in this example, our sample is 3.75. Our null hypothesis is 3. Our standard deviation is 0.85, and our sample size is 20. So the standard error is 0.85 divided by the square root of 20, or 0.19. So we would say that 3.75 is 3.94 standard errors above the mean. If we imagine this on a normal distribution, where here's our expected mean, we go 1, 2, 3. We can see that 3.94 is actually quite a bit higher than the mean. So the probability of making a type 1 error is actually really small. But we're not going to call it the alpha. We'll call it what is called the p-value. And this is defined as getting this result when we expected a neutral result, or the probability of getting 3.75 from random sampling. Step 4, we need to identify the critical value for the test. This is done by going to the t-test tables, or the t-significant tables in the back of the book. I think it's the third table in. We would find on that table that the sample size is 20, so the degrees of freedom would be 19. The alpha is 0.05, but we're doing a two-directional test, so you notice that we're splitting that between the two tails. So we find that the critical value for on the t-table in this case is 2.093, and we move to step 5. So we compare the calculated and critical values, and we reach the following conclusion. Since 3.94, or t-stat, is greater than 2.093, or a t-critical, we would reject the null. The average attitude is not neutral. Now we check the direction of the difference. Since 3.75 is higher than 3, the value of the t-statistic is positive, then the attitude is significantly positive. Thus, we can say that to the original question, the average attitude towards the Springdale Mall is significantly positive. Now, what does this really mean? There's really two statements that come out of this. First is that there is a statistically significant difference between the attitude of Springdale Mall shoppers and the expected null. And the second is that this evidence does support the claim that the attitude is positive. Notice that these two are different. Okay? It all depends on what your claim is. And I think this is where the most difficult part of hypothesis testing comes in. It was as we see that first, the test is telling us that there is a significant difference, a statistically significant difference. But we really have to go back to the claim to ask if it does support the claim. The claim is that the attitude is significantly positive. We find the evidence that suggests this, so we say the evidence does support the claim. In English, local residents do seem to have a generally positive attitude towards Springdale Mall. This may be helpful in making other marketing and strategic decisions for the company. Now, in class, we'll run these single sample hypothesis tests. We'll be using what is called the paired two-sample for means, and I'll explain more about that. But the output that we will see is as follows. We can see that the mean, just as we'd measured, is 3.75. We have to actually input the hypothesized mean, so a second column of 3's. So we're defining what the null hypothesis is. The t-stat, as we measured above, is found here, 3.94. Now, even though this is a directionality or directional t-test, we're going to use these bottom two numbers, which correspond with a bidirectional t-test. So the t-critical is 2.093 that we found from the table, but we also see this p-value. This p-value is another way that we can test, although it still will always agree with the result that we found before. The p-value is the probability of getting this result of 3.75 when we expected a 3. Notice that that probability is very low, less than 1/10 of 1%. This is much less than our alpha or decision criteria. So the p-value would also suggest that we would reject the null hypothesis just as the t-critical or t-test has done so.